Well, good afternoon, dear participants. Let me introduce myself. My name is Amanjol, and I'm a representative of Astana Hub. Thanks for taking part in the online brainstorming session today. Today, Astana Hub, together with Blockchain Hub, is having an online webinar, the topic of which is blockchain in cloud infrastructure. So before we start, please do not turn the microphones and videos on during the whole webinar time. It's necessary to not interrupt the speaker. So if you have questions, please write them down in the chat. And in the end of the webinar, we will have about 10 minutes to answer them. So the speaker of today's webinar is Rob Lewis, Head of Product Development. Right now, I'd like to turn the floor over to the speaker. So Rob.
Hi, thank you very much. And so let me tell you a little bit about myself first, and then we'll dive right into the presentation. My name is Rob Lewis, and I'm from OpenCTNet. And as indicated, we're here today talking about blockchain in cloud infrastructure. And before we get into the topic at hand, which is blockchain and cloud infrastructure, let me tell you a little bit about OpenCTNet so you get an idea of what we're up to and why this is a relevant conversation for us. OpenCTNet is a Kazakhstan-founded and based joint venture. We're based here in Astana Hub, and if you could see over my shoulder, you could see that we are based inside of the Astana Hub, and that picture that you're looking at is out of our window. We're a blockchain association partner focused on blockchain-based cloud services for telecommunications. Inside of this joint venture, we perform business development, research and development. We have our network operations center, and we provide support for our customers. So before we get into the blockchain in cloud infrastructure conversation, the first thing we need to ask ourselves is, what are the problems in the cloud? The primary problem with the cloud is that the cloud is not a cloud. It's not like there's one cloud out there in the sky. There are many clouds in the sky. And those clouds are not interconnected. They provide platform, they provide software. There's also, as part of the cloud, the telecommunications infrastructure. And those clouds are not interconnected. Additionally, the public internet is not suitable for critical applications or secure data communications. Its design center, the public internet's design center, was to be able to survive a nuclear holocaust. And that means that any node within a network can be taken out at any time for any reason, and data intended to go from one end to another will make it. It's not designed for critical applications to be able to ensure data communications or that those communications are secure. To solve that problem, or to mitigate the problem of one of the problems of the public internet, private circuits were introduced to allow for the critical applications and secure data across known private networks within the networking space. Those private circuits are costly, cumbersome, and increasingly showing more security threats. In other words, they're not fulfilling on the vision that existed for the intention of private circuits. And when you buy a private circuit, you own the circuit for a period of time, whether you use it or not. Another problem with the cloud is that multicast can't be supported. The emerging technology or marketplace called everything as a service, or XaaS, doesn't provide for tracking and monitoring, and it's difficult to keep reliable records. So everything as a service is the combination of software as a service, or SaaS, platform as a service, and infrastructure as a service into one cohesive as a service concept called XaaS. Let me introduce BAT, blockchain as a transport. What blockchain as a transport provides is the ability to connect geographically dispersed layer 2 islands. This includes different cloud infrastructure. It allows for those islands to intercommunicate across secure, known, and managed connections. With blockchain as a transport, network traffic, including unicast, multicast, and broadcast, can travel over the exact same internet or public internet segments that we have today, and it can do so seamlessly. The idea of multicast allows you to update your broadcast network instantly, every 250 milliseconds. Blockchain as a transport creates its own routing tables that allow only those nodes that are within the routing network to know about the route of data. Those routes are updated every 250 milliseconds. So when multicasting across these nodes, you can send data without worrying about the TCP/IP acknowledgement that the right data made it. You can just send data, much like you do with radio waves or analog television waves. It allows for the continuous pushing of data without the concern for the TCP/IP, did my network fail in between where I am now and where I'm trying to get my data. So that when you send a packet of information, it'll continue traversing. If a node disappears, the routing table gets updated, and the next time you send data, it'll update the routing table and send data down the new routes, allowing for dropped packets if necessary. And in a multicast, broadcast, or unicast environment, it's not necessary that your data be perfect. And we use TCP/IP to validate that data actually made it if it's necessary for data to have made it. So blockchain as a transport is a patent pending technology that combines all of these different technical concepts into one cohesive solution for blockchain in cloud infrastructure. Blockchain as a transport value is expressed in a number of different ways. First, it's secure. Networks occur as invisible because they're not on the TCP/IP routing table. They are not visible via traditional TCP/IP routing tracking. And the way that we've implemented BAT, if somebody does discover or can find that invisible network, all the bits inside of that network are encrypted. One of the major values of the blockchain is its ledger. And our ledger protects that routing table and the routes inside of the blockchain. Uniquely, the blockchain as a transport blockchain that OpenCTNet utilizes is able to perform 100,000 transactions per second. Now, to put that into context, there are two other data points you need to know. The first is that Visa performs 60,000 transactions per second. And that's globally. That's their maximum. Traditional Bitcoin takes 10 minutes to perform a single transaction. And we're able to do 100,000 transactions per second. And with current optimizations, we might be able to see a 10-fold increase or 100 million transactions per second. but we're only advertising the 100,000. It's measurable. All traffic is trackable. So that private circuit that I talked about earlier can be broken up into little pieces, and that dark fiber gets utilized. So we're able to measure things like applications, network, data, services, and utilizing the blockchain as the ledger, keep that record available for future invoicing and billing. Now, this technology ends up being more cost-effective than existing technologies, and we'll talk about that in a moment. But you can imagine the performance gain by getting to not have to use a private circuit, use an internet connection, and only pay for what you use. BAT is scalable. It doesn't have scalability issues, the kind that we're used to within the cloud. BAT is also interoperable. It works with other blockchains, designed to be able to interoperate with other blockchains. So where is blockchain in cloud infrastructure going? The evolution of blockchain in cloud infrastructure is going to follow a very easy to understand trajectory. And I'm going to walk you through the history of networking and bring you right up to today, and then point at where we're going. Initially, there was wide area network. Then the problems of wide area network became too great, and SD-WAN, software-defined wide area network, was created. And we're introducing BAT-defined wide area network, which is more secure than SD-WAN. It eliminates network complexity, and I'll show that to you in a minute visually, and supports the concept of bandwidth on demand. Wide area network was developed for the corporate enterprise to allow corporate offices and branch offices to interconnect securely. They use Metro E, dedicated circuits, MPLS for sharing data between data centers, corporate offices, and branch offices. And it worked, and that was its purpose. And in time, the problem of not having interconnected clouds of services brought about software-defined wide area network, so that there was a single resource that you were connecting to, but your networks stayed the same. In other words, the network complexity remained the same while the software centralized. In BD-WAN, the blockchain as a transport defined wide area network, we simplify the networking and we maintain the quality of the integrated cloud by reducing the number of network connections and networks, so that you only have public internet connection to your data center, corporate office, and branch office, single line, and then you can connect to any of the various services available in the cloud. And in this case, I'm referring to the cloud, an individual cloud. So where is this taking us? Where is blockchain in cloud infrastructure going to represent itself as the cloud evolves? Well, we like to say blockchain is the cloud, and the cloud is blockchain. Because once you take your blockchain-defined wide area networks and you scatter them around the world, and this colo could be in Asia, this one in the Americas, this one in Europe, and you interconnect those data centers inside of a blockchain-defined wide area network, it allows you to, within this protected, secure environment, connect to the global blockchain. So you can utilize blockchains that are not part of this protected network. We can interconnect with public cloud services so that we can connect or bring together those clouds and have them interoperate. we can then also connect with content providers and application providers and software providers and service providers to allow all of those services to interoperate within the protected blockchain in the cloud infrastructure. So what's available out of this? Where do we go with blockchain in cloud infrastructure? If the blockchain is going to revolutionize the cloud, what do we do with that? New opportunities that are emerging given this type of technology allow for a blockchain ledger for tracking and billing. And that means micropayments or microtransactions of platform, software. Imagine utilizing a software application the way that Amazon does with Lambda, where you can trigger an application and pay for it only while it's running, and then when it's not running, turn it off. And then have that applied to also your telecommunications infrastructure, your data infrastructure, your services infrastructure, your platform infrastructure, and have all of that be on demand, tracked and billed within the blockchain, and allowed to have these integrated services, or everything as a service, XaaS, enabled via the blockchain. Additionally, we'll see things like performance improvements. Because we're able to, on demand, connect in our software, our platform, our infrastructure, we're able to have these things happen when we want them to immediately, and their interconnectedness via the blockchain-based routing networks, the connected layer 2 islands, we'll see performance improvements across applications, across services, and huge new opportunities for these interconnected applications to work, which will ultimately lead to marketplace pricing. That means that for all that dark fiber, because we're able to sell off pieces of dark fiber that are not currently being utilized or unutilized or underutilized assets, you can sell them for cheaper prices, which will then put downward pressure on those applications and on those networks and on the data that's being sent through it, to bring down the overall cost of these types of applications, to unlock a whole new world of smaller applications that otherwise wouldn't have the ability to get into the marketplace due to cost, because of the cost of deploying a huge new application. Ultimately, blockchain in cloud infrastructure enables everything as a service. This concept that's been there in the world for a while now has a technology implementation that will grow rapidly. The future of blockchain in cloud infrastructure is that blockchain-based distributed ledger, and that's the primary benefit of blockchain, will replace security and efficiency holes that currently exist in traditional TCP/IP. Private circuits or network connections will be provisioned securely, efficiently, and priced based on usage, not on ownership. The public internet will be used for secure critical applications. If your connection to the internet and the applications that you're connecting to are secure by nature, then you're likely to use the public internet for those secure critical applications. And finally, and this last phrase is going to sound like buzzword bingo, and it's not. Blockchain as a transport, everything as a service, sharing economy. Now, the sharing economy is best exemplified by Uber, who saw an opportunity where vehicles were only utilized about 5% of the time on the high end. Uber allows a vehicle to be put into service 24 hours a day if possible. And that builds a efficiency in an expiring asset that allows for it to be used and bring down the cost of transportation. That same sharing economy, blockchain as a transport, everything as a service, sharing economy will provide revolutionary, cost-effective blockchain and cloud infrastructure marketplace for unknown services to date and the leveraging of existing assets in a way that has never been seen before. Thank you very much. With that, I'd like to open it up to questions.
So anyone has questions? So Rob, have you finished? Yes?
Yes, I have.
Okay, so thank you, Rob, and thanks for the participants. So the recorded version of our session will be sent by email to our participants and you. Thank you very much.
Absolutely.
So yeah, have a nice day. So
Thank
see
you. Okay.
Goodbye.
Bye.